Hello, my name is Joshua Mugabe. I welcome you to Locomotion in Paramecium. Paramecium is a simple ciliate protozoan. Ciliates bodies are covered with fine cytoplasmic hair-like structures, which we call cilia. So we are looking at a paramecium, and we are saying it is a ciliate protozoa, meaning that it has got cilia. When you look at it, it has these small structures that you're seeing coming off the membrane. Those ones are the ones that we are calling the cilia. The paramecium has a distinct and permanent shape, and certain areas of cytoplasm, those are cell organelles, are specialized to carry out specific functions. So for the paramecium, it has a distinct and a permanent shape. Its shape does not change. It remains the same. It does not form another shape like amoeba. And it is a permanent shape. And we are saying that certain areas of the cytoplasm are specialized to carry out specific function. Every part of the paramecium, we shall see different parts. It has a contractile virtue, the one we are seeing in the middle here. That is a contractile virtue. It is a cell organ and it has function. It has a very large cytoplasm. The whole area that we are seeing inside here, all that area is a cytoplasm, and it has a meganucleus which controls the basic process. This one in the middle is our meganucleus. It has also a micronucleus. It has got a micronucleus which mainly controls reproduction. It is very close to the meganucleus. It is there. That is the micronucleus. Then it has got a contractile virtue. The other side, we also saw another contractile virtue here, which was very big, occupied. Now we have this one, this contractile virtue here. This one you can see that it is halfway empty. It is filling. And this side, we can see that it is already filled. And then it has got what we are calling the food virtue. Food virtue, we can see the small organelle here, which we are referring to as the food virtue. Then here we have the oral groove. The oral groove is this area here where it feeds from. That is the oral groove. It has the cytosome, which is the cell mouth. This part here, the cytosome, which is the cell mouth. It has got the anopore. Anopore is here, which releases materials out. And it has got the cilia. That is the amoeba and the organelles that are found in different areas of the cytoplasm, and they have or they carry out specific function. Frequent movements of the cilia propel the organism through water and also create a feeding current. So we are looking at the frequent movement, the movement of the cilias. This movement of the cilias, as the cilias are moving, their movement is the one which is going to propel the organism to move into the water, through the water. And those frequent movement of the cilia also are the ones that are used in creating a feeding current. They can create a feeding current whereby they will be drawing the food material particles into the oral groove, which is moving towards the mouth, or what we call the cytosome. So that is the work of the cilia. They keep on freaking or changing shape, moving to and fro, which we are referring to as a freaking movement. And that freaking movement is the one that is going to help the organism to propel itself into or through the water. And then also they are the ones that are going to create the feeding current to allow materials to enter into the cell. Individual cilia bend and straighten rapidly in such a way that the recovery stroke offers minimal resistance, and the bending stroke helps to propel the paramecium through the water. So if we enlarge the surface of the paramecium, this is what we are going to see. These are our cilia, and this one here is the surface of the paramecium. So the cilia, when you look at them, they are attached on the surface of the paramecium. So we have the power stroke. Power stroke is this one here. As it pushes, it is going to push the water to move backwards as it is moving backwards. Power stroke. And then the recovery stroke, when it is coming back, it comes back in this direction, going backwards, so that it can go back to the normal state. So there is where we are providing a minimum resistance so that the amoeba can easily flow through the water. And then we have the power stroke. When the power stroke is hitting, it is going to push the water. And when it pushes the water, then the amoeba will move. Now, for example, if you see this one is straightened. If it is straightened like this, that means that now it is applying some pressure against the water current, and thereby that one will propel the organism to move forward. But now, when it is coming back to the straightened point, from the straightened point, there is a way it bends. As it is bending, this allows the water current to pass over the bent area. So as the water current is passing over the bent area and moving away, it is going to allow the organism to propel through water with minimal resistance. The whole complement of cilia beat in a rhythmic pattern, which we refer to as metachronal rhythm, so that the wave of contraction passes over the cell body like wind blowing through the ripe corn. So there is the cilia when they are moving and making the power stroke and a recovery stroke. It is the cilia beat which is in the rhythmic pattern. It is a rhythm, and this rhythm is moving along the whole cell body, and it is a result of the contraction of the cell wall, like as if wind is blowing through, and then you will see all the cilia bending, moving, and it flows in that direction along the cell wall. So that one, that rhythm pattern, is the one that is going to help the organism, the paramecium, to move through water. Now, if the paramecium encounters an obstacle as it is moving, like the way we are seeing here, our paramecium is moving in that direction, but as it is moving, it finds an obstacle here. So when it hits this obstacle, it means that now it cannot go in front. So what is it going to do? Now what is going to happen is that now the paramecium is going to reverse the ciliate beat, and it will move backward. So now the cilia which were moving in the opposite direction, they will now change and move in the backward direction. So the paramecium, after hitting the obstacle, the ciliate beat is going to change direction, and now it will reverse its ciliate beat in the opposite direction. And when it reverses that one, now it will move backwards. Then it will change direction slightly and starts moving forward. So we have seen, what we have seen here is that the amoeba was moving in that direction, but unfortunately it found an obstacle. As it was moving, it can now not go any further because of that obstacle. So what it does, it changes the ciliate beat. The ciliate beat is going now to change direction, and it now contracts in a different direction. Now when it contracts in a different direction, now that means that now the cilia is going to reverse. It will now move backwards. It will move backwards away from the obstacle which it has hit somewhere here. Now when it moves backwards far away from the obstacle, now it will turn slightly. It is going to turn slightly from its original to a new position. It will change to a new position. Now, it will now change to a new position, and then it will start moving forward again. So, after changing slightly, and it has changed direction, it will now start again moving forward. So here what is going to happen, after changing the direction from this direction, it changes and goes to this direction, it will now start moving forward again. Now when it moves forward again, the direction now it is taking is going to be different. If the obstacle was here last time and it hit it, but now it will go in this opposite direction and moving far away from the obstacle. So it will do this repeatedly until it gets past the obstruction. So it is moving away from the obstacle. The only way it can move away from the obstacle or bypass the obstacle is to go backwards. And when it goes backwards, it will change direction. And when it changes direction slightly, then it will come back again. When it comes back again, and again it finds that it is still hitting the obstacle, then it will repeat the same process. It will again go backwards and then change again the direction slightly. If it changes direction this time and it moves in that direction and it finds out that now there is no obstacle going in that direction, then it will continue with its journey through the water body. So this reaction also shows that a paramecium is sensitive to stimuli. In this case, it is the stimulus of touch. So because we are seeing the paramecium hitting the obstacle, and after hitting the obstacle, it will know that it cannot go any further. So it changes direction. When it changes direction slightly, then again it will change the position in a different direction, and then it will go backward, upwards. So when it goes up again and it finds that there is no obstacle in its way, then it will move in that direction, meaning that the paramecium is sensitive to the stimulus. The stimulus now is this obstacle. It's the one which is causing the stimulus, because when it comes and it reaches the obstacle, the paramecium cannot go any further. So it senses, meaning that it is sensitive to the stimulus. And when it goes back, change direction, and then come back again, and it finds that there is no obstruction, it will continue with its journey. That one is a reaction which shows that the paramecium is sensitive to stimuli. Hello, my friend. Thank you very much for participating in Locomotion in Paramecium. Please do like, share, and subscribe.